All right, so this is the one that's a little bit harder, and it's going to demonstrate the next part of this, okay? And that will let us go to the next step. Before, when we did CH4, well, we already counted for the 8 electrons just drawing in the bonds, and so we only got about halfway through the steps, just because it was so easy. All right, now, CH2O. Well, again, we're going to start in the exact same place. We look at our periodic table. We find out how many valence electrons there are for each of these atoms. Carbon is in group 4, so there's 4A right there. And so we put 4. We have our hydrogen again, which is in group 1. And so we put 1, and there are 2 hydrogens, so that has to be times 2. Just like if you got paid 2 $5 bills, you'd have $10. So, next thing we do is we look at our oxygen. Well, we see here that's in group 6. And so we have 6 valence electrons. That's going to mean this equals out 6 plus 2, 8, plus 4, 12. Excellent. So we have to account for 12 electrons. Now, which one goes in the middle? Again, we look at our periodic table. We see that carbon has the most steps to be a noble. Oxygen only has 2 steps. Hydrogen only has 1. And so it makes the most sense to put carbon in the middle. And we put carbon in the middle. All right, the next step is always going to be putting single bonds to everything else you have to account for. And so we have 2 hydrogens. So we put 1 hydrogen. 2 hydrogens, single bonds to the carbon. We have an oxygen, so we put the oxygen, single bond to the carbon. All right, notice that this is where many of you, if you've been taught those structures before, will notice a divergence from the others and me. And that's that right here, most people would have to have you assume there's a double bond or something. I don't do it. It's not a good idea. You can do it a much, much more elegant way. And so what you can do here, you don't have to know anything about this compound. You don't have to know what double bonds form, triple bonds. You don't even have to worry about any of that right now. All you have to do is account for the electrons. So count up how many have been used. We have 2 in this bond right here. We have another 2 electrons in this bond. And another 2 in this. So that's 2, 4, 6 electrons that we have used up. That means we have 6 electrons remaining. My goodness, 6 is hard to write with a mouse. All right, now, we have to account for these 6 electrons now. Well, how you're going to do that is you're going to distribute them as lone pairs. You're going to distribute these lone pairs in the surrounding atoms, not the central atom. So, we look at hydrogen here. Hydrogen has 2 electrons associated with it. We see that hydrogen only wants 2 electrons. And so we don't put anything for hydrogen, it's full. Hydrogen here, well, that again, it has 2 electrons associated with it in that bond. And it is filled up because we see from the periodic table it only wants 2 electrons. And so we look at the oxygen now. Remember, don't do the central atom yet. The central atom comes last. So the oxygen, well, that wants 8. We can see here that that wants a total of 8 electrons because it's on period 2. And so we're going to take those electrons that we have remaining and we're going to fill it up to 8. So right now it's at 2. That means it needs 2, 4, 6. So that's 2, 4, 6, 8 electrons on the oxygen. So that is now full. All right, so that's excellent. Let me explain. These right here are the lone pairs. So see how I wrote them in pairs. If you remember each orbital from the earlier work that we did when we talked about orbitals, each orbital wants 2 electrons in it. To fill up an orbital, you have to have 2 electrons in it. And so what we're really representing here is pairs of electrons filling up orbitals. That's what we're actually representing. And so, ta-da, you have accounted for all of your electrons now. That's -6, so we distributed through here. So that puts us to 0. So we've accounted for all of our electrons. We have all the ones in the surroundings filled up. Now what we need to do is we need to figure out what needs to go to this carbon to fill it up. Well, let's see. We have 2, 4, 6 electrons on the carbon already. Carbon wants, well, it wants 8, doesn't it? See that? 2, 4, 6, 8 electrons. So carbon needs an octet. It does not have an octet right now. It is short 2 electrons. So what we do is we take a lone pair on these surrounding atoms, and we're going to move that into a bond. There we go. And so I'm going to erase this right now. I would always recommend when you do these in something you can erase, so that you can erase lone pairs and any arrows you feel like you need to write. You can also really erase all these numbers once you don't need them anymore. Now, one of the things I would like to point out, however, is that when you do this at your house, I know my dots turn out really nice whenever I'm using a marker on the board or whenever I'm using a marker on paint. But if you do this with a pencil, you will not be able to tell the difference between a dot and the grains in the paper. And you will get confused, and if you turn it into anybody or try to show it to anybody, they will not be able to read it. So when you do this with a pencil, I recommend you fill the dot in, okay? Make a real dot. Now, we'll see here that now we have filled up the carbon with 8 electrons. And so it now has an octet. 2, 4, 6, 8 electrons. That gives it an octet. So the carbon here is now full. You will notice that we have made a double bond now. So again, double bond is just 2 bonds, and that would have 4 electrons in it, in the double bond. And so we have successfully completed this Lewis structure. Congratulations, excellent.